So we're going to start solving systems of equations, and the first method that we're going to use is solving with by graphing. But anyways, what is a system? What's the first thing that comes to your mind when you think of a system? Forget about math. Solar system, right? And what does the solar system consist of? Planets, right? Many things, right? You have the sun, and then you have the Earth, Moon, all these planets orbiting the sun, and that's our solar system. Or the PlayStation system. What's that? That's a gaming console, right? But it's not just the console itself. You got controllers. They even sell them separately, right? You have your games. So you have all these parts that you need to have in order for you to enjoy the PlayStation. Or a stereo system. Same thing. You have your radio, but then you might have an amplifier. You have your speakers. So it's a bunch of different things working together. So when we talk about a system of linear equations, it's really just two or more equations working together, okay? And before we used to solve an equation, now we're going to be solving a system, which is really two or more equations working together. So it could be 3 equations, it could be 5 equations, but in this first part, we're only going to be looking at 2 equations at a time, and that's what we call a system, 2 equations at once. Anyway, let's go through this opener right here together. What is a solution to an equation? Anybody? How about this? Let me break it down even easier for you. What if I gave you this equation, y, or let's say, not y, let's stick with x because that's the most common one. Let's say x plus 3 equals 5. What's the solution to that simple equation? 2. So what makes 2 the solution? Yeah, okay, because you subtract by 3. That's the process of solving. But why is 2 the answer? That's how you get 5, right? When you say the answer is 2, why? Because 2 plus 3 equals 5. And that's it. There is no other number besides 2. So what makes 2 a solution? That 2 makes it a true statement. So what is the solution to an equation? I would write down the value that makes the equation a true statement. The value that makes the equation a true statement. So I'm actually going to type that in. So there it is, the value that makes the equation true. You could say value or values. So let's take a look at part B right here. It says, name 3 solutions that work for this equation, x plus y equals 3. So give me 3 answers. Or give me 1 answer. Let's start with 1. In other words, what plus what equals 3? 1 plus 2. Now, you could write it as x equals 1, y equals 2, but the easier way of writing x equals 1, y equals 2 is in a coordinate format, 1, 2, right? What else?
0, 3.
0, 3. What else? You could switch it, 3, 0. You could switch the 1, 2 and say 2, 1. What else? You could say 1.5 and 1.5. You could technically say 4 and negative 1, 5 and negative 2, 6 and negative 3. You guys get the idea? I could say 100 and negative 97, right? How many answers are there to this 2-variable equation? Infinite. It goes forever, right? Forever. There's an infinite amount of answers. And that's the reason why we graph. Because when you graph a line, you end up putting arrows on it, right? Put an arrow and an arrow. The arrows mean that it continues forever, going this way, forever going that way. So you have an infinite amount of solutions represented on your linear graph. Okay, so I guess I kind of answered number 2A, where it says, when you graph an equation, what does that line really represent? So go ahead and write that in. So when you graph an equation, that line really represents the infinite amount of answers that exist to that equation. So let's go back. Actually, no, let's look at this next example. It says, graph x plus y equals 3. Okay? Now, if you notice, it's the same equation that we had up here, x plus y equals 3. So we have all these coordinates that we could actually plot on the xy plane. But just to review, the best way to get organized and graph a line is to make sure that it's in slope-intercept form. In other words, you would like y by itself. So let me subtract x here, and let's rewrite this thing as y equals negative x plus 3. Now, of course, we could go to a XY table and start putting in inputs and pulling out outputs, right? Like if I plugged in 0 for X, what would I get out for Y? 3, right? And that's a coordinate 0, 3. So you could plot the coordinate 0 on the X, 3 on the Y. That would be this point right here, okay? But obviously, the quicker way of doing it, instead of plugging in numbers like 0, 1, and 2, the quick way of doing it is if you have it in slope-intercept form, you already know that it crosses the y-axis at 3, 1, 2, 3, right there. And the slope is what? -1, which means down 1 over 1. Okay, so it's rise over run, so you're going to go down 1 over 1, you're going to put a dot right there. And that's your line. However, that line's really tiny if you just look at it from these 2 points. So what you would like to do is extend it using that slope pattern of down 1 over 1, down 1 over 1, down 1 over 1, so you could get that perfect line. So if you extend it in both directions using the slope pattern, you'll have this line right here. And of course, we put arrows on it. And the reason why we put arrows on it is because there's really an infinite amount of answers that'll fit in here. Like I said, 100 will fit in the X, -97 will fit in the Y. 50 could fit in the X, -47 could fit in the Y. That would give you a true statement 3. So that's why we put arrows on here, right? You could even put like -5 on the X and +8 on the Y. Now think about that. -5 on the X, -5, +8. That answer is represented with this line, because if you do go -5 on the X and you go up to -8, it's still going to be on that line. Does that make sense? So this is all review from Algebra 1, but we need a really good understanding of what the line actually means. It represents the infinite amount of answers that exist to that equation. Okay, so we said a system is 2 or more equations working together, okay? And let's actually jot that down. It's going to be super hard because it's really tiny. What's a system of linear equations? We're going to put 2 or more equations working together. There it is, 2 or more equations working together. Now, what I would like to do is just take a pause on this, on these notes that we're actually working on, and let's just go to a blank page right here. And let me do this. Let me put X. Everybody write this down somewhere in your notebooks maybe, or on a different paper. X plus Y, let's say equals, give me a number. Simple one. 4. Okay, we're going to go with 4. And let's say that if I have 2x plus y equals, let's go with 9. So what I want to do on this exercise is first show you that, guys, this is a system right here. It has 2 or more equations, right? Now, could somebody tell me an answer for this top equation? What plus what gives you 4? 2 plus 2 is 4, right? Now, if I just had a single equation, if I was just looking at the top one, I would say, yeah, 2 and 2 is an answer. 2, 2 is an answer. But since I'm looking at a system, I'm looking at both equations together, will the answer be 2, 2? No, it's not 2, 2. Why not? Because if I plug in a 2 right here, that gives me a 4, and 4 plus 2 is not 9. Does that make sense? So when I think about solving a system, if I say solve this system, right, then you need to think about the values that'll not only work for the top one, but work for the top and bottom one. Okay, so let's just do a couple of guess and checks. Anybody else? We said 2, 2. 2 plus 2 gives us 4, but 2 times 2 plus 2 does not give us 9. Anybody else have any other combo that we could plug in? 3 and 1. Okay, 3 plus 1 is 4. 2 times 3 is 6. 6 plus 1 is 7, not 9. So 3 and 1 didn't work either. We could even keep track of this. 3 and 1 did not work either. And we said 2 and 2 did not work either. I'll give you guys a hint. Think about negative numbers involved also.
6 and -2.
6 and -2, let's try that. 6 plus -2, that's 4. 2 times 6 is 12, plus -2 is 10. Super close, but not 9. 5 and negative 1. 5 and negative 1, I believe we have a winner. If we say 5 plus negative 1, that does give us 4, so that checks off the top one. If we go 2 times 5 plus negative 1, that does give us 9 on the bottom, because 10 plus negative 1 is 9. So it works on the bottom one also. So ladies and gentlemen, the answer to this system, the answer is the coordinate, we said 5, negative 1. X equals 5, y equals negative 1. Now this is the way not to do it. But do you understand it? Okay, if you understand it, that's what matters. That's why I wanted to do this. Because you understand that the answer has to work right here and here for both of them. It has to check off on both of them in order for you to find the solution to the system. Now, guys, we mentioned previously, what could I do with this equation up here? In terms of, it has an infinite amount of answers. What could I do with it? I could graph it, right? If I wanted to, I could rewrite it in slope-intercept form by subtracting x and say that the top equation is really going to be y equals negative x plus 4. Okay, that's my top equation. Now the bottom equation, I could also graph it by subtracting 2x, 2x, subtracting 2x, and rewriting it as y equals negative 2x plus 9. But the bottom line is, if we understand that if we rewrite it in slope-intercept form and graph each of them, we're going to end up with 2 lines. So let's just, I want to do a quick sketch here, all right? The top equation, the y equals negative x plus 4, that one crosses at 4, so I'm going to put a dot up here. And what do I do from there? I go down 1 over 1, down 1 over 1, down 1 over 1. So here's my sketch of that line, right? Yay? Okay, now, how about the other one? The other one crosses where? The other one crosses at 9, and it goes down 2 over 1. If you're looking at the bottom one. So it crosses at 9, way up here somewhere, and it goes down 2 over 1, so it's kind of steeper going down, and it ends up intersecting somewhere down here. Now, what coordinate do you think this is? I wish I would have drawn this better, but that's ugly. But what coordinate do you think that is? 5, negative 1. The answer that you get, obviously, if this black line represents all the answers of that top equation, and this red line represents all the answers of that bottom equation, and you're looking for that one single common answer that they both have, then you're technically looking for that point of intersection, because that's the only coordinate that both lines share, and that's the coordinate 5, negative 1. Okay, so if you understand that right now, you're understanding why we're going to solve systems by graphing. Because you know one line represents all the answers of one equation, the other line represents all the answers of the other equation. So if you're looking for that single answer that works for both, you're really looking for that point of intersection. Yay? Okay.